All right, welcome to this session. I guess it's time to start. My name is Vincent. I'm the Red Hat CTO for Asia Pacific based in Singapore, and I'm also a contributor to OS Climate. In particular, I've been looking after the stream that we call data commons. The aim of the data commons is to solve the climate data problem. So essentially, how do we get people to easily discover, integrate climate data from multiple sources into their climate risk models or requirements. So today I'm going to focus really on a key topic, which is the concept of open data product. Now, why this topic is important is if you look at the fragmentation of climate data in particular, there is no lack of data, so to speak, but it's very difficult for practitioners, academic or enterprise to actually have standardized access to this data. So one of the problems we set to solve for all the different OS climate projects, and some of them were mentioned by Michael Tiemann earlier today in his presentation, all these projects rely on the access to quality climate data to actually develop risk tooling. So we have this stream, which is data commons, which can be seen really as a horizontal stream across OS Climate to support all the different members and initiatives. So, bit of recap. So OS Climate, essentially our mission is to apply a community-based open source approach to solve the data and analytics challenges around climate. For this, we adopt an open source community approach. We look at using open source for data, for the technology, as well as the models. We have one stream, which is called the Global Data Commons, which has the goal to provide a curated library of climate data that is openly accessible, not just to our members, but pretty much anybody that actually wish to access this. And that enables people to easily integrate data with climate risk tooling or analytic tooling. Now, on the right, you see a little picture that summarizes the extent of the problem and how we deal with it. Out there's thousands of climate data sources. As you can imagine, none of them is standardized in terms of technology stack. Parquet file, SQL database, CSV, I mean, like you name it, every piece of technology out there that can store data, all the way to even DLT, somehow is being used by people to store some kind of climate data, carbon emission, and so on. So no engineer, no climate data scientist out there, even with the best skill set in the world, is going to be able to go to all these different sources and easily pick up the technical skill to integrate this data. So the way we set to solve the problem is by saying, because it's almost impossible to create one data copy that is always going to stay up to date, why don't we actually build an engine that can go and federate the data across multiple sources? So we set to build an engine following an approach that we call a data mesh. And essentially what we are delivering in this project is a self-service data management platform. So it's an open source blueprint that everyone can reuse. You can go into a GitHub repository, take the tech stack. Every single project in there is open source. The configuration is open source. You can actually take it and deploy it on any cloud provider or data center of your choice. And once you have deployed this, you have access to a set of curated data and recipe that you can deploy to pretty much share whatever data pipeline or risk tooling that you want to contribute to the community. Now, why this is important, of course, is anything that can be easily set up and replicated means there is a greater ability to have more contributors to replicate what you do and improve the recipe for future usage. So this is how we leverage the open source processes and practices within OS Climate. We have people who contribute their time, their climate expertise. We have data providers who contribute limited or open access to their data for specific purpose, like climate risk and analytics. We have people who build open models. And of course, we have technology companies, including Red Hat, that actually provide technical support on the underlying platform. So thanks to this approach, we are able first to have a transparent way of building data integration into climate data and tooling, and we are able to as well share the cost and the intellectual effort of doing this work. You have things that your organization could do on its own that would take hundreds of engineers. You can actually mutualize now the effort by reusing a lot of these building blocks. Now, one step back. Why are we here now, and what is the problem we're trying to solve? I think 3 years ago, when we started looking at the data platform, we were at the early stage of a discussion with NGFS that actually published a report on bridging the data gaps. And what this report highlighted is a huge fragmentation in the space of climate data. And in particular, the report highlighted 3 dimensions of problem that needed solving. The first one was availability of data. Imagine, I mentioned it earlier, that you have data maybe from United Nations, WRI Institute, provided to you free of charge. But this data is basically in various repositories, Git managed or not, CSV file, and so on. Availability is actually very limited, because if you need a technical person to pick this up, build a data pipeline, consume the data, build a repository, manage the lineage, look, you are talking effectively 100 of hours of development just to actually make the data usable. It's not sufficient just to have it in a file somewhere. So availability is very, very restricted for that reason. Although there is a lot of data, typically people have been reported to spend hours, weeks of their time actually making it usable. The second problem is comparability. You probably have this problem in any of your respective enterprise. How many organizations today have an issue of duplicated data that is not reconciled across the enterprise? In banking, it's crazy. I was speaking with one of my customers 3 weeks ago. He told me, as of today, he's got 25 different ways of representing the customer. So imagine, we are all talking excited about GenAI and whatever. Well, if you can't even know who is the customer, how do you actually do GenAI? We are not even there. We have a big, big data problem in enterprise. At the level of climate data, it's even worse, because we've got hundreds, thousands of providers with a lot of data duplication and no standardization in terms of how do I know how you acquire the data, how was it transformed, how is it actually managed and updated. You may actually have an update in the data source and not being actually told about it. So you don't know that maybe the data quality is poor. And so that brings me to the third pillar, which is data reliability. If you are going to use climate data into a model that you use for decision, you need to be able to trust this data. If this data is just a patchwork of 15 different sources, and none of them have some kind of quality control that can be audited, honestly, are you going to take any decision with that model? Not if it's going to have a financial consequence or a reputational consequence as well. Right? So that's really the reason why we are doing this. Now, the good news is, from a technology standpoint, we have access to a lot of really powerful technology out there that actually you use in your daily life without knowing. The likes of Facebook, Netflix, Uber, they are big tech companies who've actually been contributing open source data technology for the past 10 years or so. They are doing real-time data processing at scale, at the petabyte scale today. Now, the problem is these companies have hundreds of very trained engineers to actually support them. So your challenge is, without access to this very smart and obviously very highly paid engineer, how do you get the same capability? So this is where open source comes in. What we did with OS Climate is we curated some of the best open source data projects that have the biggest adoption. And then we built what we call a data mesh architecture, which essentially is a way to federate different data stores across to make data easily accessible. Now, why this approach is revolutionary is that in comparison to how you've probably done it in your own organization traditionally, which is kind of a data warehouse or data lake, this approach typically takes months to get the data, build pipeline, validate the pipeline quality, publish the data, And then even when you publish the data, guess what? Compliance came in and limited the access to it, and you still need to open a ticket to actually have access. I mean, I get this discussion all the time. People who tell me it's 3 months to actually get an access to their data. With a data mesh approach, we are basically looking at whether you as a user have access to the source data, the source system, which means you are using the source system policy. And then if you do, we give you a way to automatically bring the data from various systems and integrate it together. So it's a much faster approach to accessing the data, and it has a lot of interesting financial consequence as well, which is it's actually much cheaper because you are distributing the computing instead of bringing your data and paying network cost and storage cost to your friendly cloud provider just to have a replica of the data. So this is the approach that we follow, and there's 3 concepts to this architecture. The first one is we want the infrastructure to be self-service. So as a data product owner or a data analyst, you do not want or have to understand the technology that is underlying. When you want to build a data access, you should be able to push a button and pretty much get into, typically we have people using maybe Python coding or SQL to just get the data access. It's still a reasonably low level of skill that is required to kind of contribute and get access to this. You don't need to understand Kubernetes and complex, Spark data processing and so on, which are really, really sparse skills. The second aspect is we use what we call decentralized data product ownership. So in your respective organization, when people actually build a product referential, we call this a data product, and we are saying the people in the business who know the data should be the owner, not IT, not the platform engineer, because they have really no clue what this data actually means or how to check the quality. So the ownership should be rightfully the person who understands the business context of the data. That person should be the one entitled to say that I've actually done quality control and test, and these quality checks are sufficient for me to publish the data. And last, because we are all regulated institutions, or most of us around here, being FINOS, this cannot happen at the detriment of security and compliance. So people who have access to the data, they should be rightfully audited against their access, so there should be policy management. Now the good news, again, a data mesh approach, because it gives a central way to pull the data. That means you only need to work at one layer across the organization to build your data access policy. So in comparison with building your data access in possibly 50 or 100 different data sources and systems, I'm not saying it's no work, but it's significantly easier to build one set of data governance and policy in just one place. So that's the good news. Now let's take an example of this. So one of our contributors is Alliance, and we collaborated with Alliance to build a first open data product. The example we use is PCAF. So PCAF, if you don't know about it, stands for Partnership for Carbon Accounting Financial. PCAF provides standards on how to measure emission for financial product. So where PCAF is doing a fantastic job, it is actually trying to standardize how the financial industry is running their analytics to report the equivalent emission for a specific financial product. And they've actually published very, very detailed guidelines. I'm talking about 50 to 100-page document explaining for the 7 asset class that you see here, how financial institutions should be implementing the GHG accounting. So that's great, but is it sufficient? My answer is no, because I was actually explaining this earlier in a discussion that if you give the 100-page English document to 10 different institutions and 10 different engineers, they will actually implement 10 slightly different solutions. And then when you start to reconcile them, you'll be like, hey, hang on, we all read the same document. What's happening here? So with OS Climate and the concept of open data product, we are taking one additional step. We are actually codifying the implementation of the PCAF standard into open source code. So that means that anyone who is actually running the computation is going to have the same source code at the back. So you are able to compare the computation against multiple industry providers. And if there is a difference of opinion, everything is transparent. So you can just go to a GitHub repository and open an issue against the code and voice your own opinion as to why it's not maybe the best implementation or exactly correct. And so that is great in the sense that it saves you a lot of time. And you see here, the implementation itself needs access to a certain number of open data sets that you could very well integrate by yourself, but it's probably going to take you hundreds of hours to do so. So we've made this available out of the box for you to use. And because the code is open source, then people can actually criticize the quality of the output. And so this is fundamental. If you think about academia out there, a lot of the issues in terms of the finding we see from academia on climate is that when someone actually publishes a result, anybody tries to use the same method with different data and will come with a different conclusion. So arguably, using open source to collaborate around data and tooling is a way to accelerate the collaboration and the way to actually get things done if we actually want to make a difference in terms of climate research. So that goes even beyond OS climate itself. So that's a bit technical, but what you need to see from here is a couple of things. First is we use a concept that we call data as code. What it means is the data pipeline, the data transformation, the metadata management, the data quality check, everything is actually a piece of code. So any change, even if I had, if tomorrow I want to add an additional quality check in my pipeline, I will need to go in a GitHub repository, test it, open a contribution to the repo, which will be reviewed by other people, and then it will go in the pipeline, and straight away you benefit from this additional quality check. It's a very, very powerful concept to manage data as code because of reproducibility. The other aspect is you will see a few logos out there. These are a few of the open source technical projects we use to actually make the magic happen. And what's very important to know is all these projects are fully open source. That means you don't have any dependency or lock-in on any specific vendor to run this stack. If you want to run it on your laptop, it works. If you want to run it on your server, inside your own organization, it works. If you want to run it on a cloud provider, it works as well. So that's the beauty of open standards from a technical standpoint. I put here, and I think the presentation will be circulated as well, an access to the GitHub repo. So if you are interested to see how it's implemented, you just need to follow the link. Now, looking ahead, a couple of exciting things that I would like to share. The first thing is thanks to the FINOS merger, and I think it was mentioned earlier in the talk, if you were there this morning, we've realized that the work we are doing around open data applies to matters beyond climate. So an example of this is RegTech, and reg reporting. So we started to look at how we can collaborate in the RegTech space as well. And what we realized is in the RegTech space, there is another technical contributor, which is Databricks. And Databricks has been doing a lot of work on data processing and also making the standard that you see here called Unity Catalog. So Unity is an open source project that sets to standardize the way that people can actually declare and share data across multiple organizations. So this project fundamentally is going to help us deal with a few additional problems. The first problem is, great, I've solved the problem of querying data across open repository, but what if two organizations want to selectively share data with each other, but not with the whole world? With the Unity catalog, they can do this. They can document their own data model. They can document which data is open, which data can be selectively shared, and then the data and query engine are going to use those governance capability to selectively filter the data that can be shared. So that's a fantastic capability for enterprise level sharing. That means we can open collaboration with data provider who may want to contribute their data set, but only on selected usage, which means we can solve more problems as well as a result. The other aspect of it is that is going to help us extend how we abstract the underlying technology stack or how people solve the data. When you're actually going through this repository, I don't need to even know what database or technology you have at the back. I just need to go and query. The query language is actually using standardized SQL. So I don't need to know if you are doing real-time data on Kafka or NoSQL data on MongoDB. It's totally abstracted in terms of problem. So now we have this very, very powerful cross-organization sharing capability that we can implement. And that means we can go towards what I call federated governance and policy as code. So essentially, have your own organization start to manage in a piece of code who actually is the data steward, who has governance access to the data, who is a data user, and what is the kind of data elements that this user has the right to access. And then obviously how the infrastructure deployment of the solution should be deployed. So we have this vision that in the next year or so, we'll be able to fully codify even the data access and the role-based access control to data across organization. So that's what I wanted to share on the Data Commons project. And I don't know if we have a bit of time for questions, but I'll take a couple of questions if we do. Otherwise, you can find me outside and just reach out. Thank you. Yeah, sure. All right. Yeah, there's one question here.
Yeah, just thank you very much. Sir from Europe. Obviously, there's all this potential there, and then the collective action challenge of actually making it happen, like with everything of this work. But are there any changes or conversations happening with regulators in this space that might have that convening power around, let's say, a law that's already been passed, about bringing industry stakeholders to collaborate around meeting the requirements of the law, complying from, like a legal point?
Yeah, absolutely. So just to mention one example, in Singapore, we've been collaborating with the Monetary Authority as the regulator. We have a very progressive approach to ESG. They've essentially built a utility called Greenprint, which is going to manage the entire ESG reporting between the obviously industry and the financial sector. And one aspect of Greenprint is they want it to be interoperable with any other regulated, utility or repository of data from other jurisdictions. Because obviously Singapore is great, but it's quite tiny. And so one of our members, so in this case BNP, is one of the sponsors of the project. And we are actually running now a proof of concept of equivalence between the European data standard on the European data platform and the Greenprint registry. Now, the good news is the way we are approaching equivalence is, although we are testing only for 2 standards, we are going to open source the kind of rule management and approach for the equivalence inside the OS Climate project. So the approach itself is going to be extensible to any number of regulatory formats for reporting that may actually wish to have an equivalence with other people in the room. And the reason is, I've kind of stopped dreaming that we will convince all the regulators to agree on one single format. I think there's kind of zero chance of this ever happening. They all think theirs is the best. So as technologists, we realize that probably the best way for us is to use kind of a Rosetta Stone for people to convert from one data standard to the other and kind of just deal with the problem this way.
I have a question around whether you're looking also at authenticity of the data. And here, I mean, you can report that your supply chain
So it's not major now, but in fact, at the climate conference 2 years ago, we presented a proof of concept of integration with a digital ledger for emission tracking that was actually done with, I think it was Western Ontario State in Canada, if my memory serves me. And so the idea was, like you say, there was a process to actually validate and manage the quality of the data with actually a third-party auditor as well engaged. And then this way we can actually, from the point of introducing the data in the DLT, then after that we can actually manage the entire lineage of the data and prove that everything is safe. But the difficulty, of course, is always the point of entry. Like, how do you prove that the data that goes into the system is actually reflective of the reality? To some extent, we could do this with maybe IoT data. If we can have some kind of secure hardware and an ability to really integrate the whole supply chain of data from the hardware itself. But that's going to be an extremely tiny use case compared to how much data there is out there. So some sources, of course, there is way to make sure that from the pipeline we can ensure the authenticity. An example is now we are doing some work on geospatial data with IBM. So IBM has done a lot of work with NASA to integrate geospatial data from the different satellites and has been used mostly for weather prediction at the moment. What we are doing now is we're trying to bring this data from NASA and make it available to the physical risk people. So in this case, of course, because we get the data directly from the NASA server, then we can kind of put a stamp there that, yeah, we kind of own the entire supply chain from the point of generation. Of course, I mean, NASA could still kind of change the data and lie to me, but I mean, kind of hoping that it doesn't happen. Yeah.
Thanks.
So I think we are out for time. Thank you very much for your attendance. Again, I invite you to approach me anytime. Thank you.